Yes, welcome once again to this lesson, and hope you enjoyed the previous lesson. And today we are back with A-level pure mathematics. A-level pure mathematics, where we're going to be looking at the continuation from where we stopped last time, and we're looking at pure mathematics. Teacher Okata taking you through it. The topic for today is exponential and logarithmic functions. So we want to look at the exponential and logarithmic functions. And in this topic, we need to appreciate that an exponential function is a mathematical function in the form, a specific form, in the form f of x equal to a power x. That is f of x equal to a power x. Where in this case we are looking at x being the variable. So x is a variable and a is a constant. And a is a constant. X is the variable and a is a constant. And this constant a, we are calling it the base, because when you have a power, then you should have a power to a base. So a is the base, but a should be greater than 0 and not equal to 1. Greater than 0 and not equal to 1. So when you have f of x equal to a power x, that is an exponential function, because it involves a power, and a power is an exponent. Now we need to know the difference between power functions and exponential functions. In a power function, x power a, as an example, the variable in this case is the base. The variable x is the base. That is a power function. And when you look at the power, when you talk of power, I mean exponent. Power is exponent. That's why we're talking of power function. So the exponent in this case is the constant. So we're having a power as the power to x. But for exponential functions, like a power x, we see that here the base is a constant, and when the variable is a power, we call it an exponent. We call those exponential functions. We call them exponential functions. Hope you've got the difference now between power functions and exponential functions. Now you need to take note. We already seen that for power functions we can differentiate easily using the power rule. For example, when you have a power function and you know about the power rule, you know when you want to differentiate with respect to x power m, that will require you to pre-multiply the function by m, the power, and then reduce the power by 1. That is the power rule for differentiating power functions. And we saw that already when starting with differentiation at the earlier stage. However, this is not possible. This is not possible for an exponential function. This is not possible. Remember, we're looking at exponential functions and logarithmic functions. We've seen the difference now between an exponential function and a power function, which we already used too. So logarithmic functions are the inverse of the exponential functions. So when you get the inverse of the exponential function, the result is a logarithmic function. Are we together? Yes. Hope you're following and we are still moving on together. This is Video Learning Uganda in conjunction with a number of schools. Hope you're enjoying this pure math lesson. So when you have y equal to a power x, that is exponential function. So the inverse is now x equal to a power y. The other one becomes a logarithmic function. We have also seen from O level And also the earlier topic where we looked at chapter 9 in Backhouse 1, we looked at those useful topics and we dealt with logarithms. And somewhere and some stage we say if you have y equal to log of a power x, log of a of x, or you can say log of x base a, that is equal to y, it is equivalent to the exponential function x equal to a power y. We did a lot of that when we were looking at that chapter 9. So the inverse of the exponential function is the logarithmic function. Now we look at an example. In this example 1, we are saying if y equals 2 power x, that is an exponential function, find dy dx. We say the power rule doesn't work here, so we need to know the specific steps that we need to undergo in order to differentiate exponential functions. So we want to find dy dx. So in our solution, y equals 2 power x. We shall introduce natural logarithms on both the sides. Natural logarithm on both sides to y equals 2 power x. So that will give us, if we introduce, we have in of y equal to in of 2 power x. Then in of y will equal to x in 2. We are employing the law, you can call it the third law of logarithm there. So the power x comes and pre-multiplies. So we have x in of 2. And when you differentiate both sides with respect to x, we would have 1 over y dy for in y. And then differentiating the other side, we shall have in of 2 dx. When you differentiate x in 2, you get that one. Remember, we also employing here things like quotient rule, which you must know very well. But later on, we shall look at more ways of how to differentiate natural logarithm functions. So we have dy dx now as y in of 2. But remember, y is 2 power x, so dy dx becomes 2 power x in of 2. So 2 power x in of 2 is the derivative of y equal to 2 power x. We need a second example, and in this second example, we now having it in a different form. We're saying find dy dx of 5 power 2x with respect to x. And in this case, we shall let y equal to 5 power 2x and still introduce to it the natural logarithm. That is, in of y would equal to in of 5 power 2x, but we're writing there 2x. We're employing already the other third law to minimize our steps. So we have 2x coming over here, and we have 2x in of 5. Now differentiating both sides, in of y will give you 1. We shall have to differentiate both sides and get 1 over y dy for this left hand side. And then in the other side, when you apply the quotient rule there, the product rule, we shall have 2 in 5 dx. And then we need dy dx. So we have to divide by dx both sides. Dy dx will then equal to 2 in 5 times y. But y is 5 power 2x. So when you substitute for y as 5 power 2x, you get dy dx. Clearly, as you can see right there on the screen. That is our second example. This is our second example, and hope you've got how to differentiate dy dx, get dy dx for such functions which we are calling exponential functions. Now, exercise is right there. I have question 1, question 2 there for you, and then the third one is also there for you to try, as well as the fourth is also just right there for you to do. Hope you've enjoyed. I will meet in the second part of this lesson.